Hello, everybody. And for today's extra help session for Wednesday, we were talking about the 4 pages that we asked you guys to read and highlight, as well as answer the questions for, starting at page 294 and ending at 297. I'm going to be going over some of the information with you, as well as giving you at least a little bit of hint, a little bit of direction, some of the questions, while Mr. Fulton will give you the actual answers for what was on Thursday's post, which will be at 5 o'clock today. So how do air masses affect weather? Talked about air masses already. It's been in the PowerPoint. The large volume air, which temperature and moisture content are nearly the same throughout. Depending on where they form is going to be a main factor in what type of temperature and moisture. This is not on here, but this is the information I'm just going to go ahead and review with you guys. Remember, there are two different ways that can have temperature and two different ways that can describe humidity, and that mixes between the four adjectives. For humidity, if it says maritime, maritime means that it is going to have more moisture because it's going to have formed over a large body of water, usually an ocean. And then you have continental. Continental is a drier air mass because it forms over land. It's not able to pick up all that moisture as it forms like the maritime does. And then for temperature, it can be one of two different adjectives. It can be polar. Think about the North Pole. The poles are colder. It's going to be a colder air mass. They form further away from the equator, closer to the poles. And then you have tropical. Tropical means warmth. You're talking about air masses that form closer to the equator. Because remember, these air masses tend to collect the temperature from the either land or water, which they created. Kind of went over that a little bit when it came to the investigation. So in other words, there can be a combination of possibly four. You can talk about maritime polar, which means moist and cold. Maritime tropical, which means moist and warm. Or you can also have continental polar, which means dry and cold, or continental tropical, which means dry and warm. It's all based off exactly where they form and what they're collecting, either warmth or possibly moisture. For further clarification, you can go back to the PowerPoint. The next part we're going to be talking about here are fronts. Fronts are the boundaries in between these air masses, particularly how they interact with one another. A lot of weather happens at these boundaries. We'll be going over them in a second, but I just want to look at number 12 here. Identify. As you read, underline how masses form. You're going to underline part of what's highlighted. That's completely fine. It's going to be found within this section. Now on to the next page, page 295. We're going to be talking about the different types of fronts, the different types of interactions between the boundaries of air masses. You have a cold front, you have a warm front, and you have a stationary front. The first one we're going to be talking about is the cold front. Cold front is when a cold air mass pushes underneath a warm front. Because remember, colder air is more dense. Sorry about that. And when it's more dense, it's going to be sinking. It's going to be close to the earth versus warm air. Warm air is less dense. It's going to be floating more above it. So that is going to allow a cold air mass to push underneath and push the warm air mass away for a cold front. It mentions right here that storms that form along a cold front are usually short-lived, but they can be pretty intense with their rain or snow, despite only being short-lived. And cooler weather is going to be following that cold front because this cold air is going to be replacing the warm air, resulting in cooler temperature. For number 13, if you hear that a cold front is headed for your area, what type of weather might you expect? You can find that within the highlighted section, really right here. The next different type of front, or in other words, once again, how the two different air masses interact with one another at their boundary, is a warm front. The warm front forms when warm air is going to be following a retreating colder air mass. Since it's less dense, it's not really going to be pushing it in the same way that the cold air is, but it's going to be following behind it. The warm air, where it rises, the interaction between cool and warm is going to be resulting in the moisture condensing into clouds. And where the warm fronts are, it's going to usually be drizzly rain followed by warm, clear weather, because that warm front is going to be replacing the warm air mass is going to be replacing the cooler air mass once that front moves on. For number 14, identify. The rainy weather at the edge of a warm front is a result of, I'll give you a hint on that one. It's the only line we did not highlight within that paragraph. And then the third type of front is a stationary front. The stationary front is when the winds are not enough to push either one, and that either air mass, so the air masses are going to kind of stay put with that boundary remaining generally within the same area. A stationary front is going to cause unchanging weather, usually clear, and that's usually when, if one of them is moist, when some of that moisture ends up dissipating, it'll cause clearer weather. Remember, stationary means it's unmoving. So the stationary front is when the two different types of air masses aren't strong enough to really move each other. And then the next 2 pages, we have 296. The only main part of this one that you need to know is what we have highlighted. A high pressure system results when air sinks slowly down, because high pressure, it's cooler, it's more dense, so it's going to be sinking. Versus a low pressure system, air rises because it's going to be warmer, and warm air being less dense rises. Now, there's a lot of information there, but the highlighted ones, like Mr. Fulton said, on Mr. Fulton's video previously, the highlighted parts are the only ones you really need to know. Number 16, identify. Choose the correct answer for each of the pressure systems below. Using those highlighted sections, just read this. It should make it pretty self-evident. And then the last page is going to be talking about how different pressure systems affect us. We've talked about this a little bit, how high is dry, high pressure systems equal drier weather, versus low pressure system. Low is lousy, that's going to create rainier weather. Looking at the highlighted parts right here, it's repeating what it said over there. High pressure systems are areas where air sinks because it's cooler, more dense, and it moves outwards. It's going to be pushing some of that moisture away. It's going to result in a lower relative humidity, because remember, cooler air has less space in there to hold water vapor, to hold moisture. High pressure systems generally result in clear skies, calm and gentle breezes. So remember, high is dry. It's going to be drier weather. Versus a low pressure system producing rainy weather, low is lousy. As air at the center of the low pressure system rises, it cools and forms clouds and rain. The rising air in a low pressure system causes stormy weather. So remember, high is dry, low is lousy. And then for the last section that you should be answering for, number 17, match. Label each of the pictures as a result of high pressure system or low pressure system. Then draw a line from each photo and its matching air pressure diagram. So in the blank spaces right here for A, you can say whether that's high pressure or low pressure, high pressure or low pressure, and then you will be drawing the lines to which one it matches on the right. I'll just give you also a little bit of a description. Put your mouse on here. This A is a sunny day in Central Park, New York City, versus B, a rainy day in Central Park, New York City. So that covers Wednesday's lesson. If you guys have any further questions, please have your parents email or Edmodo message Mr. Fulton or myself, and we'll make sure that we're all understanding everything. In the meantime, please make sure you're keeping up with everything for both, not only science, but for all your other classes too. Please continue to remain safe and healthy, and I will see you next time.